Right now, we are going to go to the next level. I just gave you the general introduction about what is the relationship in the chemical bond in the periodic table and overall, general relationship. Hope you got an idea. And then we got a little bit of the fun dog video that makes us to understand what is sharing, what is transferring, right? So those are all things we got an idea about it. Now we have scholars right here with them, me, not just me and the scholars. So we both are going to share our thought about what exactly the bond is and what types of bonds and everything. We're going to go over really quick, and then I have a super fun activity. It's just like for 5 to 10 minutes. So that makes us to understand very clearly the scholarly station. After we done this, we will be moving forward to that. Are you all clear? Everybody understand my English, right?
Yes.
Okay, good. All right, good. Let's go. Yes, sir.
Chemical bond. A quick review is a bond results from the attraction of nuclei for electrons. All atoms are trying to achieve a stable octet. In other words, the protons in one nucleus are attracted to the electrons from another atom. This is electronegativity. What did the atom of fluorine say to the atom of sodium?
What is the name of the what do we call for it? Can you help me out?
Fluorine?
Fluorine. Yeah. What is that?
Ethyl.
Yeah, right. Oh, okay. So what do we say for that? Yeah.
Sodium is Mg.
You just naming the compound, right?
Oh.
Okay. Yeah.
Sodium is Na.
Oh, okay. All right.
Sodium is Na. And then
Yeah. And sodium. What is the
Na.
Na? Okay. All right. Let's go.
You complete me.
Okay. All right.
There are three major types of bonding.
This is something very. I'm sorry for the interruption. This is something very, very important that we got to understand this. Okay. Go ahead.
There are three major types of bonding. The first type is ionic bonding, which forms ionic compounds and transfer of valence electrons. Second is metallic bonding, and third is covalent bonding, which forms molecules, shares valence electrons, and this is basically our focus for this chapter.
Okay, great. So that's the main focus of the chapter. Okay, now who's going to be elaborate other than presenter? Who can elaborate about the ionic bond?
Ahmed.
Go ahead, Ahmed. Talk, tell me anything you like. I mean, you know it. That doesn't matter whether it's right or wrong. I'll take it.
Transfers from valence electrons.
What is that?
It transfers from valence
He's,
electrons.
okay, he's saying a transfer from valence electrons. That is the main thing he said it. Well said it. You know the answer. So each vocabulary is very important. Transfer from valence electron. What is valence electron? Now that's the question. What is the valence electron?
Electrons on the outer shell.
Electrons on the outer shell. Okay, can I draw a structure of sodium so that you can see it where the valence electron is going to be? What is the element name for the sodium? Na, that's right. What is the atomic number for sodium? 11, okay. Now, I'm drawing the structure of the sodium right here. What do we have in the middle? Okay, nucleus. What do we have outside the nucleus?
First shell.
First electron shell, right? Alright. How many electrons is going to be in the middle? I mean the first shell.
2.
That's right. Okay, now. Are we done? No, okay. How many is going to be on the second shell?
8.
8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Are we done?
No.
Okay. How many we have in the outermost electron? Only one electron. Okay. So now the question is, either it needs 8 electrons to fill it, or this one needs to be go away. This one needs to be go away. So that's what they are talking about in the ionic bonding. Forms an ionic compound, transfer of valence electron. The valence electron, which is right here, this is called valence electron. I know you guys know about it. I just wanted to make sure we are clear about what exactly the valence electron are. The outermost shell. Right? Well said. Thank you. Keep going.
Mister, it's right here.
Right here. Oh, thank you. Now,
Ionic bonding. Always formed between metal, H, cation, and non-metal ions. The opposite charge ions stick like magnets.
so the good example is metals and what do we see in the periodic table?
Metals, non-metals, and metalloids.
Metals. There you go. All right. So we just talked about it, right? What is that? Lost electron and gained electron. Okay. What does that mean? Metal plus non-metals. Can someone give me the example for that?
Positive charge.
Negative charge. Okay. Which is going to be a metal?
Positive
For
charge.
example, table salt. Now tell me that. I'm telling you the answers. Table salt, which is sodium chloride, right? Table salt, we consider it like. So sodium chloride, which is right here, right? Which guy is going to be positive? Which guy is going to be negative? Which is metal? Which is non-metal?
That is
Na is a metal, that is right. Ma is metal and Cl is non-metal, that's right. Okay, now the question is, why this guy is positive, why somebody is negative? Why?
because sodium is a metal and chlorine is a non-metal.
Okay, why do we call it as like, the sign right here? Do you all remember that? This guy, 1 electrons in the outside. Are you all following me? What is he? What is he doing? He is giving. That's right. He is totally is a transmitting. The donor. The donor is always. Donor is always. Donor is always become. Receiver always. That's a simple concept. You are clear? Okay. Let's move on.
Metallic bonding always formed between two metals, pure metals, solid gold, silver, lead, etc.
Okay. So what is the main difference between? I just want to see the difference between covalent ionic and metallic. Covalent, we just talked about it. What is that? Yes, sir.
Equal sharing of electrons.
Okay. Ionic is?
Ionic
Yes.
is like
Transferring electron. That's right. Okay. Now, talking about the metallic. What is the main difference between the covalent and ionic? Yes, sir.
Main difference between one is metallic, is purely just metals, two different metals.
Two different metals, but what is the connection? The free flow of what?
Electrons.
That's right. There you go. You see right here. So the free flow of the electron all over. So that's the main difference between the covalent and ionic and the metallic. Are you all clear? Can we keep continue? Let's go. Okay, now we coming to the covalent one, which we know that. I just wanted to make sure students are very clear about the bonding, and then we can move on to the next activity. All right. So covalent bonding is right here. Go ahead.
Pairs of electrons are shared between two non-metal atoms to acquire the electron configuration of a noble gas.
Okay. What is that? What does that mean?
Pretty much two non-metals are connected to make a noble gas, or to be stable like a noble gas.
Okay, so the noble gases, you all know that in the periodic table on the right hand side all the way down, all of them is completely completed the outer shell. They are all non-reactive, which you all know that from the periodic table unit, right? So can you all refresh that? Yeah. So those are the information. All right.
Covalent bonding occurs between non-metal atoms which need to gain electrons to get a stable octet of electrons or a filled outer shell.
Yeah. So that's what I just draw this little the diagram. I mean actually not done by me. The students did it. Right. So they just put that block diagram of the periodic table and separated like metals and non-metals with the staircase which is right here. That is the main difference right here that occurs between non-metals atoms which needs to gain electrons to get the stable octet of the electrons or filled outer shell. The ultimate purpose is what is the ultimate purpose of the bonding and everything? Can someone tell me, like, in general?
To be stable.
To stay, that's it. To make it stable. If I am going to turn on the heater in the car seat, how long I can keep it? After a while, you know, I mean, I can sit, like, if it is too hot. If I want it to be stable, everything should be in normal room temperature, right? I'm just giving an example. Here is very simple, super simple. What the ultimate purpose is, all these guys in the periodic table, yo, you be careful and then be stable. We help you. We find a partner for you to make you feel comfortable, be stable. There you go. That is the main purpose. Are you understanding what I'm talking about?
Yes.
Everybody's clear? Okay. Alright. So, got it? Now, okay. Let's go on the properties of the covalent bond.
Properties of covalent bonds. One, they have much lower boiling and melting point than ionic compounds. They can exist as solids, liquids, or gases. They are usually softer substances than ionic compounds, and they are usually poor conductors of heat and electricity.
Have you all followed that? I was just not checking with the students. Okay. So, all of them like. Okay, let's move on to the non-polar covalent bond.
Non-polar covalent bond occurs when two atoms equally share a pair of electrons. The diatomic element, the
Diatomic elements. That's right.
Yeah, elements are examples of molecules containing a non-polar covalent bond.
Okay, so that's a good example of the hydrogen and hydrogen bonding. Right. Now, the next important part is the polar covalent bond. What do you all know about the polar covalent bond? Yeah, so they still share. So when you see the name is covalent, which is like, you know, in chemistry synonyms, covalent means sharing. So that's very simple. But the polar covalent still they share, but it's just like, you know, a little bit dancing, you know, each other. Like, yeah, equal, right? That's what, you know, main theme, right? All right. Let's move on to the next activity. All right. Thank you so much. Appreciate you all. All right. So as of now, what we did, we have, like, you know, discussed about the fundamental definition of what exactly the family of the periodic table, the elements of the family which is the periodic table, and we talked about, like, a little bit of what is that? The definition of the basic definition of the covalent, ionic, and metallic. Okay. Now, according to our agenda, so we are going to moving on to the wonderful activity which is called the station. I'm going to invite the station master to distribute that station folder. So, what does that mean? You will get this folder. Every station, we have 6 of them right here. The 6 stations are here. Each of them will have an activity, like one of them have a covalent, one of them have ionic, metallic, polar covalent, and then summary of, you know, the bonding and then application. There are many things in there. Okay, whoever gets this folder, you know, you have a clear direction when you open the folder. Make sure your group is completely engaged together to discuss everything. Once we are done, we will be summarizing. Are you all clear?
Yes.
Thumbs up. Okay, let's move on. Station master. Where is the